What is Voyager 1? No spacecraft has gone farther than NASA's Voyager 1. Launched in 1977 to fly by Jupiter and Saturn, Voyager 1 crossed into interstellar space in August 2012 and continues to collect data. Voyager 1 and its sister ship Voyager 2 have been flying longer than any other spacecraft in history. Not only are the Voyager missions providing humanity with observations of truly uncharted territory, but they are also helping scientists understand the very nature of energy and radiation in space, key information for protecting future missions and astronauts. Each Voyager carries a message, prepared by a team headed by Carl Sagan, in the form of a 12-inch 30-centimeter diameter gold-plated copper disc for potential extraterrestrials who might find the spacecraft. Like the plaques on Pioneers 10 and 11, the record has symbols to show the location of Earth relative to several pulsars. The records also contain instructions to play them using a cartridge and a needle, much like a vinyl record player. The audio on the disc includes greetings in 55 languages, 35 sounds from life on Earth, such as whale songs, laughter, etc., 90 minutes of generally Western music including everything from Mozart and Bach to Chuck Berry and Blind Willie Johnson. It also includes 115 images of life on Earth and recorded greetings from then U.S. President Jimmy Carter, 1924, and then UN Secretary-General Kurt Waldheim, 1918-2007. Fuel source in Voyager 1. The Voyagers traveled too far from the Sun to use solar panels. Instead, they were equipped with power sources called radioisotope thermoelectric generators, RTGs. Voyager 1 in detail. NASA's Voyager 1 was launched after Voyager 2, but because of a faster route, it exited the asteroid belt earlier than its twin, having overtaken Voyager 2 on deck. 1977. It began its Jovian imaging mission in April 1978 when it was about 165 million miles, 265 million kilometers, from the planet. Images sent back by January 1979 indicated that Jupiter's atmosphere was more turbulent than during the Pioneer flybys in 1973-1974. Beginning Jan 30, 1979, Voyager 1 took a picture every 96 seconds for a span of 100 hours to generate a color time-lapse movie to depict 10 rotations of Jupiter. On February 10, 1979, the spacecraft crossed into the Jovian moon system and in early March, it discovered a thin ring circling Jupiter less than 19 miles or 30 kilometers thick. Among the most interesting findings was on Io, where images showed a bizarre yellow, orange, and brown world with at least 8 active volcanoes spewing material into space, making it one of the most, if not the most, geologically active planetary bodies in the solar system. The presence of active volcanoes suggested that the sulfur and oxygen in Jovian space may be a result of the volcanic plumes from Io, which are rich in sulfur dioxide. The spacecraft also discovered 2 new moons, Thebe and Métis. Perhaps the most interesting target was Titan. Images showed a thick atmosphere that completely hid the surface. The spacecraft found that the moon's atmosphere was composed of 90% nitrogen. Pressure and temperature at the surface was 1.6 atmospheres and -292 degrees Fahrenheit, -180 degrees Celsius respectively. Atmospheric data suggested that Titan might be the first body in the solar system, apart from Earth, where liquid might exist on the surface. In addition, the presence of nitrogen, methane, and more complex hydrocarbons indicated that prebiotic chemical reactions might be possible on Titan. Following the encounter with Saturn, Voyager 1 headed on a trajectory to escape the solar system at a speed of about 3.5 astronomical units, 325 million miles or 523 million kilometers per year, 35 degrees out of the ecliptic plane to the north, and in the general direction of the Sun's motion relative to nearby stars. Because of the specific requirements for the Titan flyby, the spacecraft was not directed to Uranus and Neptune. Following the encounter with Saturn, Voyager 1 headed on a trajectory to escape the solar system at a speed of about 3.5 astronomical units, 325 million miles or 523 million kilometers per year, 35 degrees out of the ecliptic plane to the north and in the general direction of the Sun's motion relative to nearby stars. Because of the specific requirements for the Titan flyby, the spacecraft was not directed to Uranus and Neptune. What is Solar System Family Portrait? On Feb. 14, 1990, Voyager 1's cameras were pointed backward and captured about 60 images of the Sun and planets. The first portrait of our solar system is seen from the outside. The images were taken when the spacecraft was about 40 astronomical units from the Sun, 3.7 billion miles or 6 billion kilometers. A mosaic of those images became the pale blue dot image made famous by Cornell University professor and Voyager science team member Carl Sagan, 1934-1996. The image has also been called the Solar System Family Portrait, even though Mercury and Mars can't be seen. Mercury was too close to the Sun to be seen, and Mars was on the same side of the Sun as Voyager 1, so only its dark side faced the cameras. Why the cameras of spacecraft was turned off. These images were the last of 67,000 images taken by the two Voyager spacecraft. Their cameras were turned off to save power and memory for the Interstellar mission. Voyager Interstellar mission. All the planetary encounters finally were over in 1989 and the missions of Voyager 1 and 2 were declared part of the Voyager Interstellar mission (VIM), which officially began Jan. 1, 1990. The goal of the new mission is to extend NASA's exploration of the solar system beyond the neighborhood of the outer planets to the outer limits of the Sun's sphere of influence, and possibly beyond. Specific goals include collecting data on the transition between the heliosphere, the region of space dominated by the Sun's magnetic field and solar field, and the interstellar medium. On Feb. 17, 1998, Voyager 1 became the most distant human-made object in existence when, at a distance of 69.4 astronomical units from the Sun, it overtook Pioneer 10. Entrance into heliosheath. On deck. 16, 2004, Voyager scientists announced that Voyager 1 had reported high values for the intensity for the magnetic field at a distance of 94 astronomical units, indicating that it had reached the termination shock and had now entered the heliosheath. The spacecraft finally exited the heliosphere and began measuring the interstellar environment on August 25, 2012, the first spacecraft to do so. On Sept. 5, 2017, NASA marked the 40th anniversary of Voyager 1's launch, as it continues to communicate with NASA's Deep Space Network and to send data back from 4 still-functioning instruments: the Cosmic Ray Telescope, the Low-Energy Charged Particles Experiment, the Magnetometer, and the Plasma Waves Experiment. The two Voyagers are now over 11 billion miles, 18 billion kilometers, from the Sun and far from its warmth. To ensure the vintage robots continue to return the best scientific data possible, mission engineers in 2019 began implementing a new plan to manage them. The plan involves making difficult choices, particularly about instruments and thrusters on the spacecraft. In August 2012, Voyager 1 became the first spacecraft to cross into interstellar space. How long will it take to Voyager 1 to cross solar system? However, if we define our solar system as the Sun and everything that primarily orbits the Sun, Voyager 1 will remain within the confines of the solar system until it emerges from the Oort cloud in another 14,000 to 28,000 years.